Indicial equations, or we can call them exponential equations. So indicial equations are basically equations that are having indices in them. I'm very well, thank you, Vikiela. I'm very well. So initial equations are equations that are having indices, all right? So you have an equation like 2 raised to the power x equals to 20, all right, or equals to 8, for example. This is an equation. Remember when we did the algebra, we talked about equations. So this is an equation, right? And this is having an index, right? Indices talks about power. So this is what we call an example. This is an example of an initial equation. So this is an example of initial equation. Now, how do we solve such equations? How do we solve such equations? How do we solve? Yes, we just started, Vicky. So let's take some examples. Number one, 3 raised to the power 2x. 3 raised to the power 2x equals 27. 3 raised to the power 2x equals 27. We are told to find the value of x. So in this equation, what is x? That's the question. 3 raised to the power 2x equals 27. What is x? No, I didn't teach on Monday. I did not. I couldn't come live. I was tired. So 3 raised to the power 2x equals 27. What is the value of x? That's the question. Still on indices. Now, we are going to be, Mommy Ebi, good evening to you. Welcome. We are going to be applying still the laws of indices. Remember the laws of indices. The laws of indices. Law 1 says that's the law of addition. So when you have x raised to the power a times x raised to the power b, they are going to have what? You're going to add up their powers, right? So you're going to have a plus b. Then the second one is the difference, right? Subtraction. So if it were to be division, you're going to subtract their power. And the third one, that anything raised to the power of 0, anything raised to the power of 0 is 1. 5 raised to the power of 0 is 1. 10 raised to the power of 0 is 1. 20 raised to the power of 0 is 1. 1 million raised to the power of 0 is 1. So that's that. Then we also have the negative index. So if you have x raised to the power minus 1, x raised to the power minus 1 is 1 over x, right? So if you have x raised to the power minus 2, that will be 1 over x raised to the power 2. Don't forget, x raised to the power minus 1 is the same thing as 1 over x raised to the power 1. But x raised to the power 1 is the same thing as x, alright? So I don't need to put a 1. Now x raised to the power 2 will be 1 over x raised to the power 2, right? So x raised to the power 3 will be 1 over x raised to the power 3. So the law says x raised to the power minus whatever, any negative index, that it's going to give you 1 over x raised to the power 8. So that's that one. We also have this one that says x raised to the power of let's say a in brackets raised to the power of b. Now these powers will multiply, right? And then you have x raised to the power a b. Okay. We also have where we have x raised to the power a, y raised to the power b, all raised to the power c. This power outside affects this and affects this as well. Hello IDK, good evening to you. Maruf, hello, welcome. Hello, evening, welcome. Good evening, welcome. So x raised to the power a times c times power c will give you x raised to the power ac, and y raised to the power b times power c will give you y raised to the power bc. Alright, so the laws of indices applies here. So we're going to solve this one now. So 3 raised to the power 2x equals 27. What you want to do here is to first make this 27, alright? Express this 27 in index form, alright? Express this 27 in index form in a way that it's going to give you the same base. You're going to be having the same base. 3 here is called the base, and this one up here is called the index, alright? So the base and the index. The index, that's the power, alright? So you have 3 raised to the power 2x equals 27. Well, I have said 3 over 2. Okay, we're going to see about that. So we want to express this one now in index form. So what number, or like I said, we want to try to make them the same base. So can we have 3 raised to the power anything to give us 27? Is 27 first of all a multiple of 3? Yes. So 3 raised to the power what will give us 27? 3 times 3, that's 9. 9 times 3, that's 27. So it means that 3 raised to the power of 3 times, alright? If you have just 3 times 3, that's 3 raised to the power 2, alright? So over 3 times 3 times 3 will give us 3 raised to the power of 3. So we can now express 27, right? Good, 3 raised to the power of 3. So we have 3 raised to the power of 2x equals 3 raised to the power of 3. Now whenever you have this, okay, and the bases are the same, what we're going to do is to drop our bases and equate the power for us to get the value of this x that we are looking for. So we're going to drop the bases. So we're going to drop the base, we're going to drop this 3 and drop this 3, and then we're going to equate the power. In other words, our 2x here would now be equal to 3. So we're going to have this cancel this, right? So you have 2x equals 3. 2x equals 3. Now, this has brought us to what now? Algebra. So what are we going to do here? What are we going to do here? Let me ask us. 2x equals 3. What are we going to do? 2x equals 3. What are we going to do? What are we going to do? So this is algebra. We divide by 2. Even if we divide both sides by 2. Okay, good. Good. Make it to submit to the formula. Yes, Presley, that's what we're going to do, but how are we going to do that? Okay, Philip said divide both sides by 2. I only said divide both sides by 2. Quadri said divide both sides by 2. Make it to submit to the formula. Okay, that's the quotient of x. Yes, evening 2. Yes, quotient. So divide both sides by 2. Divide both sides by 2. Divide exactly. So we need the value of x, right? What we're going to do is to divide both sides by the coefficient of x, which is what? 2. So we need to eliminate these 2. So we divide by 2. Divide also by 2. Then 2 cancel 2, and our x now equals 3 over 2. So x equals 3 over 2. Now that's the value of this x, which is expressed as 1 number 1 over 2. That's the answer. That's what x is. 3 over 2. 1 number 1 over 2. Can also be expressed as 1.5. Please tell me when you will reach it. The birth, I don't know. I don't think I'll be able to tag anybody. We just have to come live and check. So, what level of maths is this? Indices. You have indices in the junior secondary, yeah. You have indices in the senior secondary. Great teaching. Thank you very much, Mandy. So that is that for number 1. I would like to wipe this off now. Can I clear this off? Can we go to example number 2 so we can work on another one? Let's repeat the explanation. Where's the G? Okay, so the question again was 3 raised to the power of 2x equals 27, right? So we were told to get the value of x. 3 raised to the power of 2x equals 27. Now what we want to do is to make both sides, try to make both sides expressed in index form, right? So try to express 27 in the index form, right? And try as much as possible to get a number that will be the same base with this one so that we can eliminate the bases and equate the powers. When you have something like this, 3 raised to power something, 3 raised to power something, in an equation, you can cancel out the bases, alright? Drop the bases and then you can equate the power. Alright, so if you check 27, can we have 3 raised to power anything that will give us 27? Yes. 3 times 3 times 3, that's 27, right? 3 times 3, 9, 9 times 3, 27. So that's 3 raised to the power of 3. So that's how we got our 3 raised to the power of 3 here for 27. Now what do we do? So we can cancel out these 2 3's. 3 cancel 3, or 3 drop the bases, right? Then you equate the powers. So you're going to have 2x now equal to 3. 2x equal to 3. Alright, what are we going to do at this point? We are going to divide both sides by 2 because we need the value of x. We need to cancel out these 2. So for us to do that, we are going to take the reverse operation, which is 2. Alright, so dividing by reverse operation, which is divide, right? Division. So we are dividing by 2. And according to in algebra, we said you don't do anything on one side alone. Alright, if you do anything on one side, you have to do the same on the other side. So if you add anything here, you add here. If you subtract, you subtract. Alright, both sides. If you divide here also. Alright. If you multiply also. So now 2 over 2 over 2. So 2 counts to 2 and x equals 3. So now 3 over 2, that's how we got the value of x to be 3 over 2. Alright, that's one whole number 1 over 2. So I hope you understand that. Alright, let's move on to number 2. Example number 2. So example number 2 says, example number 2 says, if 4 raised to the power of x equals 2 raised to the power of 1 over 2 times 8, can I find x? If 4 raised to the power of x equals 2 raised to the power of 1 over 2 times 8, find x. That's the question. So solution. Let's write out that question again. So you have 4 raised to the power of x equals 2 raised to the power of 1 over 2 times 8. So is there a way that we can express these numbers in index form that we're going to have the same base? Make all of them to be of the same base. Yes, IDK. So how do we do that? What can we do to make all of them in the same base? Because all this. So what can we do to make all of them the same base? What can we do to make all of them of the same base? IDK, yeah. So what can we do? King George said base 2, okay? Alright, so we're going to express them in base 2, right? So 2 raised to the power of 40 is going to give us 4. 2 raised to the power of 40, this is already expressed in base 2. Base 2, good. Okay, so 2 raised to the power of 40 will give us 8. 2 raised to the power of 40 will give us 4. Philip says 2 raised to the power of 2, good. Round them up to base 2, good. So for 4, we have 2 raised to the power of 2, which is still raised to the power of x, right? So raised to the power of x. So 2 raised to the power of 2, which is 4, raised to the power of x, equals 2 raised to the power of 1 over 2 times, how about 8? How about 8? No, Jane, we're not square rooting. Mrs. Fadipa, yes, 2 raised to the power of 2. How about 8? How can we express 8 in base 2? The J-Max say 4. For 8 is 2 power 4. No, 2 raised to the power of 4 means 2 times 2 times 2 times 2. That's 2 multiplied 4 times. That's going to give us 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So it's already more than 8. So we need 2 raised to the power 3. Good. So we have 2 times 2, which is 4. 4 times 2, which is 8. Alright, so for 8, we are going to be expressing it as 2 raised to the power of 3. Alright, so at this point, we have our bases equal. But before that, let's open up this bracket. This is in bracket. Remember the rule that says x raised to the power of a, bracket raised to the power of b, that these powers can be multiplied, right? So you're going to have x raised to the power of ab. So that can be applied here. So multiply this power, this 2, by this x. So you're going to have 2 raised to the power of 2x. So that will give us 2 raised to the power of 2x equal to 2 raised to the power of 1 over 2 times 2 raised to the power of 3. Now, before we drop the bases, if you look at these two, remember the addition rule. The addition rule, okay, you've gotten your answer? Okay, let's see if you're correct. The addition rule of index says what? That x raised to the power of a times x raised to the power of b will give us what? X raised to the power of a plus b. In other words, when you have two numbers multiplying each other and they have the same base, they are going to do what? You're going to add their powers. So if you have 3 raised to the power of 2 times 3 raised to the power of 5. Now, because they are the same base, 3, your answer will be what? 3 raised to the power of 2 plus 5. So that's 2 plus 5. That will give us 3 raised to the power of 7. So the same thing can be applied here. So what we are going to be doing all through is to apply these rules of indices, alright? So we can apply that here, the same base, 2 and 2. So we can add up the powers. Now what will it give us? So you're going to have 2 raised to the power of 2x equals equal to 2 raised to the power of 1 over 2 plus 3. So 2 raised to the power of 1 over 2 plus 3. Now the question you want to ask is, so what is 1 over 2 plus 3? What 1 over 2 plus 3 give us? That's 3.5. That's 3 over 1 over 2. 1 over 2 plus 3. That's 3 whole number 1 over 2. Or if you need to add it up. So let's see. So over 1, then what's your LCM? LCM is 2. 2 into 1. 1 times 1, 1 plus 1 into 2. 2 times 3, 6. That's 2, 6 plus 1, 7. That's 7 over 2, right? 7 over 2 equals what? 3 over 1 over 2. So that's 3 over 1 over 2. That's in case you were asked to add up whole number with fraction next time. Just combine them. 1 plus 1 over 4. 1 plus 1 over 4. 1 over 1 over 4. 10 plus 3 over 2. 10 over 3. By the way, 3 over 2 is 1 over 1 over 2. So you add it up, it gives you 11 over 1 over 2. And so this gives us 2 raised to the power of 3 whole number 1 over 2. Express this in form of, okay, you have 2 whole number, 2 raised to the power of 2x equals 2 raised to the power of 3 whole number 1 over 2. Now what are we going to do next? From the number 1 example, now we have this. What are we going to do next? Abduganu, you are here. How are you doing? So what are we going to do next? What's the next thing we are going to do? What's the next thing we are going to do? We equate the power exactly, Coach Dami. We are going to drop the basis, okay? Just like we did in the first example. Yes, we equate the power. So we are going to what? We are going to drop the basis, right? Then what? Equate the powers and cancel the exactly. So you are going to have 2x equal to 3.5. So 2x equals to 3.5. Now this point, what are we going to do? Don't forget 3.5 is the same thing. Maybe you want to express it as 7 over 2 still. Alright? Maybe you want to express it as 7 over 2. So what are we going to do? What are we going to do? Divide both sides by 2, okay? Divide both sides by 2. Thank you, official spirit. Thank you for the rules. Thank you for the rules. Official spirit. So what are we going to do? Divide, we'll cross multiply, quadri, we'll cross multiply, comrade Ojo, okay? Divide both sides by 2, okay? Cross multiply, good. So let's cross multiply, or we're dividing both sides by 2, the same thing, alright? So we're going to have 2x multiplied 2, that will give us 4x. Equals 7. So now, what are we going to do again? Divide both sides by 4, which is the quotient of x here. Divide by 4, divide by 4. So over 4 cancels. Let me write it up there. So this times this will give us 4x equals 7. So divide by 4 and divide by 4, 4 cancels 4, and x equals 7 over 4. 7 over 4 is going to give us what? 7 over 4 is going to give us what? 1 number 3 over 4. That's the value of our x. Yes, Abdugani, you got it. Good one. Yes, coach, that means 7 over 4. So that's our answer. I'm going to explain one more time. Let me go back. Hello, welcome. Oh, Lina, I don't understand. Okay, I'm going to explain one more time. Stuart, you're welcome. So now the question says 4 raised to the power of x is equal to 2 raised to the power of 1 over 2 times 8. Alright? So for us to solve this, alright, okay, let's write out that question. So for us to solve this, just like we did in the first example, so you want to express these numbers, in a way that the basis will be the same thing, alright? Express them in a way that the basis will be the same thing. Looking at the numbers alone, you know that 2 raised to the power something will give us 4, 2 raised to the power something will give us this, 2 raised to... Thank you for the roses, Legit. Thank you very much. Legit 5, thank you. Thank you, Advocate, also. Thank you. I appreciate it. And 2 raised to the power something will also give us what? 8, okay? So let's do that. Now, 2 raised to the power what give us 4? That's 2 raised to the power 2. Thank you again, Advocate. I appreciate it. Thank you. So 2 raised to the power 2 now raised to the power of x, right? So equals 2 raised to the power of 1 over 2, which you already have here. Then times 8. 8 is expressed as what? 2 raised to the power of 3, right? So according to the rules of indices, whenever you have x raised to the power of a raised to the power of b, x raised to the power of a raised to the power of b, then you multiply this, right? It becomes what? X raised to the power of ab. So the same thing we did here. So 2 times x becomes 2 raised to the power of 2x. 2 raised to the power of 2 times x, 2x, right? So equal to 2 raised to the power 1 over 2, which you have here, then times 2 raised to the power 3. I love what you're doing. Thank you very much, Coach David. 2 raised to the power 3, which we have here. Now, we apply another law here, the additional law, that says that when you have x raised to the power of a times x raised to the power of b, when you have two numbers, the same base, two numbers of the same base, right? Maybe 2 raised to the power 3 times 2 raised to the power 5. Now, because they are the same base, what you are going to do is to add up the powers. So if you have 2 raised to the power of 3 times 2 raised to the power of 4, your answer will be what? 2 raised to the power of 3 plus 4, which is 7. Alright, so that's what we did here. You did that here. You add up the powers, so you have 1 over 2 now, plus what? 3. So what is 1 over 2 plus 3? 1 over 2 plus 3 gives us 3 over number 1 over 2. So we have now 2 raised to the power of 2x equals 2 raised to the power of 3 over number 1 over 2. Then the next thing for us to do here is to drop the bases. Hello Nick, welcome Nick Tina, how are you doing? So drop the basis, and then you have 2x now equals 3 over number 1 over 2. 3 over number 1 over 2, just I have to change to improper fraction so that we can operate on it, alright? So 3 over number 1 over 2, that's how we got this 7 over 2. 2 times 3, 6 plus 1, 7 over 2, for in case you don't understand. Then what's the next thing we did here? We cross multiplied. 2x times 2 gave us our 4x there, no space, so I have to write up there. 4x then equal to 7, right? 4x equals 7. And what's the next thing? Because we need the value of x, not 4x. Yes, 4x equals 7, but what is x? So dividing by 4, right? Divide both sides by 4. So 4 cancels 4, and x equals, what's 7 over 4? 1 over 3 over 4. Alright? Oh, the one says it's magic. It's not magic. Is the network disturbing? Is the network disturbing? Oh, deep freezer. I teach here in Anambra State. Next question. Okay, another example. I never like this Excel because Odunwaya, good evening. Welcome, Odunwaya. Good evening to you. All right, let's go to example number 3. So example number 3 says, given that, by the way, this is a NECO question. So given that 9 times Given that 9 times 3 raised to the power of 9 times 3 raised to the power of this 1 plus x. Okay. 9 times 3 raised to the power of 1 plus x equals 27 raised to the power of minus x. Okay. So raised to the power of minus x, find the value of x. Find the value of x. So given that 9 times 3 raised to the power of 1 plus x equals 27 raised to the power of negative x, find the value of x. Divide the body to 3 because of space, because I believe in my time. Okay, Coach Sammy, thank you. So given that 9 times 3 raised to the power of 1 plus x equals 27 raised to the power of minus x, find the value of x. Alright, solution. So we have our question. 9 times 3 raised to the power of 1 plus x equals 27 raised to the power of minus x. The same thing applies here still. Exactly what we did in the previous examples, we're going to do here. If you look at this 9, look at 3, look at 27, that tells you something. Take every digit to the base of 3, exactly, yes. So these are multiples of 3. So we can express 3 to a power that will give us 27. We can express 3 to a power that will give us 9. This already is expressed. We already have 3 raised to the power of something, alright? So we can express 9 as 3 raised to the power of something and 27 as 3 raised to the power of something. So 3 raised to the power, what will give us 9? 3 raised to the power, what will give us 9? Yes, we are putting all in the same base, exactly, that's what we want to do. So 3 raised to the power, what will give us 9? Which that means it's 2, okay? So the very say 2, 3 raised to the power 2, Evelyn says 2, base 3. Did you study maths? I did not study maths as a subject, but I did maths. I did civil engineering tech, so I did maths. 3 raised to the power of 2 will give us 9. So we have 3 raised to the power So we have 3 raised to the power of 2 times 3 raised to the power of 1 plus x equals about 27. Thank you for the roses. Thank you, Bede. Thank you. The venerable. Okay, what about 27? About 27. 27. 3 raised to the power of what will give us 27? Thank you again, Advocate. Thank you for the rose. Thank you. Evelyn says 3. Okay. Bede says 9. Power 3. Bede says 9. 3 raised to power 9. No, it will not give us 27. It's actually 3 times 9 that will give us 27. So we want to express 3 to the power that will give us 27. 3 to a power that will give us 27. So that was 3 times. How many times? How many places? It is actually 3 times 3 times 3. Alright? That will give us 27, which is 1, 2, 3. So 3 raised to the power of 3 times. So if you have 3 times, so 3 raised to the power 9 actually means 3 times 3 times 3, 9 times. 3 times 3 times 3 times 3 times 3 times 3 times 3, 9 places. Yes, 3 raised to the power of 3. So we have 3 raised to the power of 3, all raised to the power of minus x. Alright, so we have 3 raised to the power of 2 times 3 raised to the power of 1 plus x equals to 3 raised to the power of 3, all raised to the power of minus x. Apart from subtraction, multiplication, and addition, that's all. It depends. There are some questions where you have to do, you have to express something to the power of 0. Alright, you have to apply that rule, knowing that x raised to the power of 0 equals 1. What if, for example, what if this were to be 1? For example, this were to be 1, then you have to express this becomes 3 raised to the power of 0. Don't worry, maybe we'll see an example like that. So let's open up this bracket. So this multiplies this multiplies this. I don't know how to send it, but write your account on the board. Oh, IDK, thanks very much. I hope I won't be punished by TikTok. Okay, 3127 333400. It's First Bank. 3127 333400. First Bank, Augustine Okoye. Thank you very much. Remove the bracket on the other side by multiplying minus x by 3. Good. So we are going to open up this bracket. We are multiplying this 3 by what? Minus x. Remember, the rule says x raised to the power of a, bracket raised to the power of b. Lawrence, why are you laughing? Bracket raised to the power of b. What will happen? We're multiplying a and b, right? So you're going to have x raised to the power of what? ab. So we're going to apply that rule here. And then you're going to have 3 raised to the power of 2 times 3 raised to the power of 1 plus x equals 3 raised to the power of 3 times minus x minus 3x. So now what are we going to do next? Thanks for sharing the live and thanks for the likes. Please, let's keep our tapping. Let's keep our tapping so that others can be. Alright, what do we do next? What are we going to do next? Which bank? Okay, it's First Bank. Yeah, I said First Bank. First Bank. No, I'm not giving us the Union Bank. First Bank. What's your timetable for teaching maths? We come live Mondays, Wednesdays, and Fridays. Every Mondays, Wednesdays, and Fridays. Okay, so we are going to draw our bases, right? So we have 2. Oh, I forgot to look at this here. Before we are dropping our base, look at what we have here. We have 3 raised to the power of 2. We have 3 raised to the power of 2 times 3 raised to the power of 1 plus x equals 3 raised to the power of minus 3x. So look at what we have here. Remember the law that says what? X raised to the power of a times x raised to the power of b. That will give you what? X raised to the power of a plus b. That you will add up their powers, right? So that's exactly what we're going to do here. 3 raised to the power of 2 times 3 raised to the power of 1 plus x. Before we're going to equate, alright, equate the power, we need to deal with this first, just like we did in the number 2 example. So this is going to give us change of subject. We take the powers to it. So this will give us 3 raised to the power of 2 plus 1 plus x. 1 plus x equals 3 raised to the power of minus 3x. This, if you understand what I just did, can I see thumbs up? If you understand what I did here now, can I see thumbs up? Whoa, thank you very much. King Destiny, thank you very much for the gift. Thank you. Appreciate it. Okay, can I see thumbs up if you understood what I did here? At all? Oh, really? Okay. Okay, but better said at all. Okay, let me explain. So the rule again says that x raised to the power of a, right, times x raised to the power of b. That anytime you have something like this, you have a number raised to a power times another the same number, the same base, all right, another number but of the same base raised to its own power. What you are going to do, your answer will be the same power, all right, the same base. Our answer will be x also raised to the power of adding the two powers, a plus b. That's when you have multiplication, right? This is called the addition law. So that x raised to the power of a times x raised to the power of b. Some light on linear programming. Oh, that's not yet. So x raised to the power of a times x raised to the power of b will give us x raised to the power. Let me take an example of real numbers. So we have 3 raised to the power of 2 times 3 raised to the power of 5. So this is an example now. If you have two numbers like this, right, both of them are expressed in index form and they are having the same base, what happens is that your answer will become 3 raised to the power of 2 plus 5, 7. And that was what we applied here, according to the rule of indices. One of the rules, alright? The x stands for a number, exactly, it stands for any number, we call them variables. So that's what we did here. So 3 raised to the power of 2 times 3 raised to the power of 1 plus x now will give us what? 3 raised to the power of add these powers, alright? Gives you 2 plus 1 plus x, okay? So you have equals to 3 raised to the power of minus 3x. At this point, we can now drop the bases and what? Equate the powers. We can now cancel this base, and equate the powers. I hope you understand that. For those that did not understand, Benedict, do you understand that? Do you understand, rather? Thank you very much, Timmy. Do we understand now? Do we understand? Can we continue? Can we continue? Oh, shall we say I don't understand? The second say yes. Everything will be 3x raised to the power of 2. Okay, go ahead. Alright, yes, understood. Alright, so let's continue. So now, this will give us 2 plus 1 plus x equals minus 3x. So 2 plus 1 plus x equals minus 3x. So we want to collect like this here. By the way, 2 plus 1 is 3, right? 2 plus 1 is 3. Oh, IDK, was that you? Or is that you? Have you sent it already? Hello, AMT, welcome. But how did you get the plus changed to minus? What plus changed to which minus? IDK, thank you very much. I just received it. Whoa! Thank you very much. Alright, IDK, God bless you. Thank you. I am grateful. Thank you. Alright. How do I oh, just once you are up to 1,000 subscribers, you can go live. Thank you very much. Can we go for break? When did we start and when are we going for break? Alright, so we have 2 plus 1 plus x equals minus 3x. I can wipe this off now. So 2 plus 1 is 3. 3 plus x equals minus 3x. 3 plus x equals minus 3x. So we are going to collect like terms, right? What are the like terms here? X and minus 3x, like terms. So let's collect these two together and leave 3. So we're going to have 3 now equals minus 3x. Now plus x comes to this side and becomes what? Minus x. So we have minus 3x minus x. What is minus 3x minus x? What is minus 3x minus x? And that reminds me, someone was asking how I change plus to minus. Change which plus to which minus, please. Which plus to which minus? What is minus 3x to minus x? Minus 3x minus x. Coach Nami says minus 4x. Mukta says minus 2x. But hey, I forgot. Happy Salah to all the Muslims in the house. Happy Salah. I'm not a Muslim. Maybe that's why I forgot. Happy Salah, every Muslim in the house. I hope you had a wonderful celebratory day. I hope your day was good. Alright? Oh, Aisha, you're here. Welcome. Okay, so minus 3x minus x. Minus 3x, Baraka de Salah, yeah? So minus 4x, good. So we have 3 equals minus 4x. 3 equals minus 4x. Good. Someone might be asking how we got to minus 4x. Don't forget that minus x is the same thing as minus 1x, alright? So you have minus 3x minus x. Minus x is the same thing as minus 1x. So what is minus 3 minus 1? I told us the last time when you have numbers like this, minus 3 minus 1. Now when you have the negative number, when you have minus, right? See it as what you are owing. Am I in Lagos now? I'm in Anambra State. Alright, see it as what you are owing, and when you have plus, see it as what you are having. It makes it easier for you to solve. So minus 3 minus 1, so I'm owing 3 and I'm owing 1. So I'm owing 4, alright? So minus 4. And that's how we got our minus 4x. Alright, sir? That's how we got our minus 4x. So now we are looking for the value of x. What are we going to do next? Yeah, Lord Kelvin. So what are we going to do next for us to get the value of x? Divide both sides by minus 4 quadric. Okay, so we're going to divide by minus 4, divide by minus 4. So minus 4 cancel out minus 4, and x now will be equal to 3 over minus 4. X will be equal to 3 over minus 4. And x equals minus 3 over 4. This is the same thing as minus 3 over 4. 3 over minus 4 equals minus 3 over 4. So that's our answer. Any questions so far? Any question? Omo hard though. But is it hard? Is it hard? Any question? Any question? A question? Okay, Latifa, what's your question? Bravo, thank you, Dokolo. Coach Dami said it's easy, Abi. I swear it hard, okay? Any question? Kong says so simple. Hello, Kong, how you doing? If I have no question, great. Can we do more? Yeah, we're going to do more. The Bible said, okay, let's try another one. Let's try another one. So the next question says, where's it now? Okay, x raised to the power of 4, number 4, right? X raised to the power of 4 equals, into bracket, 0.25 raised to the power of 2. X raised to the power of 4 equals bracket 0.25 raised to the power of 2, that's square. So what are we going to, I need a programming language. No, I don't do computer programming language. English. Oh, Vikiela, okay, this is what we have for today. Some jam questions. You might have some questions on indices, yeah? It's like the ladies are getting it and we the guys. Okay, let's pay attention. So x raised to the power of 4 equals 0.25 raised to the power of 2. First off, whenever you see a decimal like this, what you want to do is to first express it as fraction. And in the last class, remember, I said when you are expressing 0.5 as fraction, alright, for you. Okay, let me ask first, what will 0.5 be as fraction? What will 0.5 be as fraction, as a fraction? Change the decimal to fraction, exactly. What will 0.5 be as a fraction? Coach Dami says 5 over 10, thank you. Elegant says 1 over 2, okay? Abella says 1 over 2, 1 over 2, 5 over 10, 1 over 2, 5 over 10. Okay, good, good. So 1 over 0.5, for you to express any decimal, alright, as a fraction, what you want to do is like close your eyes to the decimal point. So you have just 0.5, alright? What is 0? 0.5 is the same thing as 5, right? Remember that the 0 in front is insignificant, it has no value. So this is the same thing as 5, right? Or even if you just want to put your 0.5. So over, you have just one decimal place. In other words, how many numbers after the decimal point? Just one number after the decimal point. So you are going to have 1 power of 10, right? That's 1 0. But if you have 2 numbers, for example, you have 0.54, that will give you, close your eyes to the decimal, 0.54, right? 0.54, which is 54. So let me just put 0.54, which is 54, alright? Over what? Over what? 2 decimal places. So I'm going to have 2 zeros, which is 2 powers of 10, right? 2 zeros because you have 2 decimal places. So if you have 3 decimal places like 0.254, that will give us what? 0.254 over what? 1, 2, 3. 3 decimal places over 1,000. 3 zeros. So this is how you express fraction as a decimal, rather, as a fraction. What if you have 1.2? What if you have 1.2? Are you going to throw away this one because you've been taking out all the zeros? No, the same thing. Like it's going to give you 12, right? Ignore the decimal, you have 12. So you have equals to 12 over, now one decimal place, so 1 0. So you have over 10. So 1.2 is 12 over. So that's the same thing you want to do here. You have 0.25, you want to try to express it as a fraction. Oh, Polowski says, I don't understand. Polowski, 1.2, anytime you have decimal, alright? Anytime you have a decimal number, okay, what you want to do to express it as fraction is to first, thank you, what's the name now? Thank you for the rose. Oh, there is no name here, but thank you for the rose. Thank you for the roses. Thank you. Thank you. So what you want to do is to close your eyes to the decimal point. What are you seeing? Just 12, right? So 12 over, it's either going to be over 10, over 100, over 1,000, over what now? 10,000, over 1 million, 100,000. Thank you, Anthony, for the rose. Thank you. I appreciate it. So now, what will determine your denominator is how many places, how many numbers after the decimal point. Thank you again. Thank you for the finger. Thank you. So how many numbers you have after the decimal point will determine how many zeros you are going to have here. Okay, so if you are having just one number after the decimal point, you are going to have 1 0. If you have two numbers, you're going to have 2 zeros. That's 100. If you have three numbers after the decimal point, two numbers like 1. So like you're having, say, 2.54. Now 2.54, that's you're going to have 254 right over something. 254 over. So two decimal places, that's two numbers after the decimal point. And you're going to have, yes, correct, good. 254 over 100. No, not 25. 2.54. That will be 254 over 100. If it were to be just 2.5, right? That will be what? 25 over just one number after the decimal point. That's 10. Alright, that's how to change decimals to fraction. So now what do you think 0.25 will be in fraction? 0.25 here. What will it be as a fraction? So ignore the decimal point, you have 0.25, right? 0.25 is the same thing as 25. Why? Because this 0 is insignificant. Just like, let's say you are going for a group competition or something, and you are number 01, 02, 01 is the same thing as 1, right? Because the 0 in front is insignificant. It has no value, right? It's useless. So this 0 here is insignificant. It's the same thing as 25. So I can write it as 25, right? So over, you have two decimal places. So you're going to have 2 zeros. This is 0.25 as a fraction. So 0.25 as a fraction will give us 25 over 100. Good. So now let's express this as a fraction. So when you have a decimal, change it to fraction. So this is going to give us x raised to the power 4 equals what? 25 over 100 all raised to the power of 2 according to the question. So x raised to the power 4 equals 25 over 100 raised to the power of 2. Yes, good. So now, what can we do here? We can divide this, right? We can break this down to the lowest term, right? 25 here 1, 25 here, 25 can go in 100, 4. Even if you use 5 to break down, at the end of the day, you are still going to arrive at 1 over 4. So 25 here 1, 25 here 4, right? So you're going to have x raised to the power of 4 equals 1 over 4 all raised to the power of 2. I hope we are following. 1 over 2. I hope we are following. Can I see thumbs up to be sure that we are all following? Can I see thumbs up? I knew the next. Can I see thumbs up? Alright, thumbs up so I can continue. Yes, we are fit. Good. Okay. So now what do we have here? Remember this rule of index. Thank you, Shivaro. Thank you for the rose. Thank you for the roses. Thank you. So remember the rule of indices that says when you have a negative power, for example, x raised to the power of -1 will give you 1 over x. X raised to the power of -1 will give you 1 over x, right? So we can also go do a reverse, right? From this to this. So that means 1 over x can be written as x raised to the power of -1, right? 1 over x can be written as x raised to the power of minus, I lost, where can we find you? Mitonitro, don't worry, I'm going to explain again. Okay, so 1 over x can be rewritten as x raised to the power minus 1, alright? So we can write 1 over 4 in that same form, and it's going to give us what? X raised to the power of 4 equals 4 raised to the power of minus 1, all raised to the power of 2. That's, we've just written this one in this form. Just the same way we can write 1 over x in this form. Are we getting this? Are we getting this? House Makela, thank you for the thank you for the roses. I appreciate it. Thank you. Thank you. God bless. So now we've just changed this to this. Are we getting this? Yes, good. So what's the next thing we are going to do? What's the next thing we are going to do? What are we going to do next? Now we can multiply these two powers. Remember the rule that says x raised to the power of a or bracket raised to the power of b. What happens? You multiply a by b, and this will give you what? X raised to the power of what? ab. So the same thing we are going to do here. We multiply our minus 1 by 2. What is minus 1 times 2? Thank you very much. Thank you. Thank you. House Makela. Thank you very much. Why don't you deal with the denominator? Which of the denominator? Which of the denominator? Why don't we deal with this one? Who was asking? Thank you again. Thank you, House Makela. Thank you for the roses. Oh, Queen Betty, where have you been? Where have you been? Good evening to you. Okay, so where were we? So this now, minus 1 is going to multiply 2, and then you're going to have what? Minus 2. So we have x raised to the power of 4 equals 4 raised to the power of minus 2. X raised to the power of 4 equals 4 raised to, exactly, thank you. 4 raised to the power of minus 2. So what are we going to do here? Since we need the value of x, what can we do? Remember this, that for x raised to the power of 2 equals, say, 5. What are you going to do to get the value of x? What are we going to do? Okay, AMC. So what are we going to do to get the value of x here? If you have x raised to the power of 2 equals 5, right? X squared equals 5. What are you going to do to get the value of x? Oh, Miguel, alright, good night. Find the root. What root? Third root, fourth root, fifth root. Which of the roots? The square root. Good. Because we are having 2, right? We're going to do the reverse operation. The reverse of square is the square root. Alright, so it's just like raised to the power of 2. X raised to the power of 2 will be cancelled out by the square root. The square root is 1 over 2, right? So it's like we are multiplying. Let me not even go there so that you don't get confused. So we're going to take, for raised to the power of 2, we are going to take the square root. For square, rather, we're going to take square root to cancel this power. So for raised to the power of 4, we are going to take fourth root to cancel this 4. I hope you're following. So for raised to the power of 4, we are going to take the fourth root. If it's raised to the power of 3, we are going to take the cube root, right? I hope we're following. I need to be sure that we're following. Raised to the power of 4, we are going to take fourth root. If it's raised to the power of 2, we are going to take square root of both sides, right? So if this is x squared equals 25, we need x, we're going to take square root and square root. So square root cancels this, and x equals 1 square root of 25. We're done. Okay, good. Okay, great. We're following. So that's exactly what we're going to do here. Alright? So for us to get the value of x, we're going to take the fourth root of this and the fourth root of this. We're going to take the fourth root of this and the fourth root of this. The fourth root of this and the fourth root of this. So the fourth root of this will cancel this raised to power 4. Just like the square root of x squared equals 25 square root. So the square root cancels the square, and x equals square root of 25, which is 5, right? So the fourth root also will cancel the raised to power 4. Thank you very much. So what do we have now? We have x now equals what? The fourth root of 4 raised to the power of minus 2. Now that brings us to the rule of the fraction index that says when you have x raised to the power of, say, 1 over b, x raised to the power of 1 over b. Let me wipe off this. So the rule that says when you have x raised to the power of 1 over b, that this will be expressed as, if you have a fraction as index, if you have a fraction as your power, all right, the denominator in the power will become the root. So this will be written as the bit root of x. So that the bit root of x can be expressed as x raised to the power of 1 over b. So if you have the square root of x, it can be written as x raised to the power of 1 over 2. Okay, that's scattered. Sunday, what is scattering, please? The right hand side should have plus or minus in front of the root. The right hand side should have plus. Okay, I understand. So if you have where am I now? Praise God, people, another day. Okay, let me explain again. I need us to explain what I'm going to do here. Scattered seriously. Okay, but do we understand to this point? Do we understand to this point? Do we understand to this point? Let it not scatter, because let us hold it together. Let it not scatter. Let us hold it together. Oh, do we understand? Good. We understand to this point. So now what we are going to do is to express this thing in form of what's it called now? Index. This root 4. We want to express it as index form. So 4 raised to the power of minus 2 raised to the power of 1 over 4. That's what this thing will give us. That's what I'm trying to explain. Alright? So the fourth root is raised to the power of 1 over 4. That's what it will give us. Alright? Yes. We're going to do that. We are going to do that till we finish and then I go back. So fourth root can be raised to the power of 1 over 4. Just like bit root of x can be expressed as x raised to the power of 1 over b. Bit root of x can be expressed as x raised to the power of 1 over b. Yes, we are applying the rule. Yes, we are applying the rule. So the fourth root of x, of 4, can be expressed as 4 raised to the power of 1 over 4. So that's the root of 4. I'm a Form 2 student, but I have a problem with the indices. Okay, that's what we started indices last 2 or last 3 classes. So there's a video on YouTube. Maybe you want to go to YouTube and search for Learn with Austin 101 and check our video on indices there, so you can start from the beginning. Amen. All right. So maybe I need to wipe off this and then we're going to come back. No problem. So we have this now to give us x equals 4 raised to the power of minus 2 all raised to the power of 1 over 4. Alright, let me finish and then I go back again to explain, maybe to help us better. So now x will be equals to, we multiply the powers. So minus 2 times 1 over 4. Well done, thank you very much. Minus 2 times 1 over 4. So 2 here 1, 2 here 2. And then you have what? Minus 1 over 2. So that's what it's going to give us, minus 1 over 2. That's the answer. Now let me go back again from the beginning and explain. Alright, so what's our question again? Our question says x raised to the power of 4 equals 0.25 all raised to the power of 2. Please let's pay attention, alright? Let's pay attention. So what are we going to do? The first thing is what? Decimal. Express in fraction, right? After learning all this, okay? So express in fraction. What is 0.25? YouTube link, okay? Learn with Austin. On YouTube, learn with Austin 101 straight line. Alright, together all at the end. Oh really? Okay, I mean I'll see that. So learn with Austin 101. Now we want to change. I think I'll have to go. Let me try to go slower. So we want to change this decimal, alright, to fraction. We want to change this decimal to fraction. Alright. So what will 0.25 be in fraction? As I explained earlier, it's going to be what? 25 over 100, right? So you are going to have x raised to the power of 4 equals what? 25 over 100. That's what 0.25. 0.25 is 25 over 100, alright? So all squared. This point, I believe this is understood, right? Now what is the next thing? If we break what we have here down, divide it, 25 here 1, 25 here 4, it's going to give us what? 1 over 4, right? So you're going to have x raised to the power of 4 equals 1 over 4 all raised to the power of 2. Alright? X raised to the power of 4 equals 1 over 4 all raised to the power of 2. Alright? Now another way we can even solve this is for us to eliminate this 4 by taking the root saying x raised to the power of 4 raised to the power of 1 over 4. Can I wipe off this? So raised to the power of 1 over 4 is also another way of saying the fourth root, alright? 1 over 4. But let me not use that. Let me explain the way I explained earlier. So you have x raised to the power of 4 equals 1 over 4 raised to the power of 2, right? Now let's change this. Let's change this 1 over 4. 1 over 4 is written as what? 4 raised to the power of minus 1. And so that's going to give us x raised to the power of 4 equals 4 raised to the power of minus 1. That's 1 over 4. 1 over 4 is 4 raised to the power of minus 1. I hope we're following. Where is 1 over 4 coming from? That's 25 over 100. When you break it down, it's going to give you 1 over 4. 25 over 100. When you divide this, alright? 25 can divide both of them. It's a common factor. 25 here 1, 25 here 4. Or you want to use smaller numbers like 25 over 100. You want to use 5, for example. 5 in 25 is 5. 5 in 100 is 20. 5 can still divide, right? 5 here 1, 5 here 4. So you have 1 over 4, whatever way you choose to divide. So that's where the 1 over 4 came from. Now the 1 over 4 has been written as this, right? So 1 over 4 is expressed as 4 raised to the power of minus 1. For those of you that are saying very simple, it's because you've understood. Allow others to understand. So x raised to the power of 4 equals to 1 over 4 written as 4 raised to the power of minus 1. Now squared. Don't forget your square. If we have a power inside the bracket, how are we going to do that? Inside the bracket. What do you mean? You mean like 2 raised to the power of 2 raised to the power of 3? If you have something like this, then you multiply the powers. It's simple. Yeah. So now, this raised to the power of 2. Don't forget that 4 raised to the power minus 1 is another you changing 1 over 4, right? Yes, good. So that's raised to the power of 2. Then we apply the rule that says what? You're going to multiply these powers, right? So minus 1 times 2. Minus 1 times 2 will give us minus 2. So we have x raised to the power of 4 equals 4 raised to the power of minus 2. This is what we have, right? So now what are we going to do next? Am I missing something? 1 over 4 raised to the power of 2. 4 raised to the power minus 1 raised to the power of 2. Minus 2. Okay. So what are we going to do next now? What are we going to do next? We are going to take what? The fourth root of both sides. Alright? I explained, like if you have x raised to the power of 2 equals 25. I believe we should understand this one already from the indices we did earlier. That for you to clear the square, you're going to take what? The square root, right? Square root cancels square. In other words, I can write square root as raised to the power of 1 over 2. According to the laws of indices, I can write square root as raised to the power of 1 over 2. Right? Because the denominator now in the index becomes the root. Do we understand? Maybe I should try using this method, maybe to help us. Do we understand this one? That the denominator in the index becomes the root. Do we understand that? That when you have x raised to the power of 1 over 2, that the denominator becomes the root. Do we understand that? Okay, that's the rule actually. We're trying to understand. Okay, that's the rule of index. That's one of the rules. I listed the rules the last time, and we talked about each one, and then we gave examples. So the rule says, right, that when you have, where is it now? That when you have this, yeah, when you have x raised to the power of 1 over a, for example, right, that this can be expressed as a root of x. A root of x. Remember, a is just a letter that's representing a number. So assuming a now were to be 2, so it becomes the square root of x. If it were to be 3, it becomes the cube root of x. If it were to be 4, it becomes the fourth root of x. Are we following? So fourth root can also be written as power of 1 over 4. I hope you understand. So maybe those that are not really full, maybe they were not here from the beginning, alright? So now, where are we? So we need to get what? The fourth root of both sides, so that the fourth root will cancel this 4. So I can do it this way and say raised to the power of 4, or I can also say x raised to the power of 4 raised to the power of 1 over 4. That's another way of writing fourth root. Right? So instead of me putting this way, alright, because at the end of the day, I'll still come to this way. I'll still come to this, right? So I can express it this way, and it has to be both sides. So if you fourth root this side, you have to find also the fourth root of this side. So you have 4 raised to the power of minus 2 raised to the power of 1 over 4. Let me know if we are following. Do we understand what happened here? Do we understand? Thank you, Anthony. Do we understand what I just did here? Please take time. We're confused. Oh, Nanake. Exma said no. Yes. Yes. Okay. Oh, Aisha, you understand? Great. Larex, you don't. Martins, no. Yes. Yes. No. I'm almost finished. Please don't be finished. Okay. Yeah, the X is here. Okay. Let me go back. We need to understand this before we go to the next example. All right. So I said that fourth root, alright, so fourth root of a number, if I don't want to say the square root of 4, I can express the square root of 4 as 4 raised to the power of 1 over 2. If I don't want to say the square root of 4, if I don't want to write it this way, I can write it this way. That's what I'm saying, alright? Thank you, Ahmad. If I don't want to write the square root of 4 this way, what I'm saying is that we can write it this way as 4 raised to the power of 1 over 2. Why? Because the denominator in your power becomes the root. And in this case, what's our root? 2. What's our denominator? 2 becomes square root of 4. So square root of 4 can be expressed as 4 raised to the power of 1 over 2. So if I have the cube root of, say, 125, I can rewrite this as 125 raised to the power of what? 1 over 3. Alright? Thank you. So if you have, let's say, fifth root of 125, I can rewrite it to be 125 raised to the power of, it's another, instead of me writing this way, I can also write it, it's the same thing. It's entering now, right? Good. Alright, so that's exactly what we did here. Alright, maybe that sign was confusing us, so let's try the other way. So if I'm going to take the fourth root of both sides for me to cancel this, so I express it as x raised to the power of 4, the fourth root, which is 1 over 4, and also the fourth root of this side, which is 4 raised to the power of minus 2. This is our number here, raised to the power of 1 over 4, and this is our number here, raised to the power of 1 over 4. So that's what we did. Entering now, good. So x raised to the power of 4 raised to the power of 1 over 4 equals 4 raised to the power minus 2 raised to the power of 1 over 4. That's what we did here. Do we understand this? Do we understand this? Do we understand what we did here? Do we understand what we did here? I need to, please, let's keep our tapping, and then, yes, good, okay. So what happens now? The other rule says, yes, good, okay. The rule says we are going to now multiply these powers. Remember again, x raised to the power of a raised to the power of b. You multiply the powers, okay? So this is going to give you x raised to the power of a, b. We're going to do it here. So we have 4 to multiply 1 over 4. 4 times 1 over 4. 4 times 1 over 4. So 4 here 1, 4 here 1, you have 1, alright? So 1 over 4 times 4 will give us 1. Because 4 cancels 4. So you have x raised to the power of 1 now, right? And anything raised to the power of 1 is x, alright? I guess that's the way you get the power of 1 over 4. Oh. So, but don't worry, let's just continue. We're on point, great. So x raised to the power 1 equals minus 2 times 1 over 4. Minus 2 times 1 over 4. We have minus 2 times 1 over 4. So 2 here 1, 2 here 2. Minus 1 times 1 will give us minus 1 over 2. So we have minus 1 over 2. So we have 4 now, raised to the power of minus 1 over 2. But you created confusion when you use square root and what you are doing at the end. Okay, now I'm using another method. I hope you understand now, right? So you have x raised to the power of 1 equals this, right? Minus 2 times 1 over 4 gives us minus 1 over 2. So x raised to the power 1 is the same thing as what? X, right? So we can now get the value of our x. X now will be equal to, now what is 4 raised to the power of minus 1 over 2? Now we can introduce our square root, alright? So what is this? When you see negative here, alright, negative index means you're going to reciprocate this. That's one of the rules. Alright? Means you are going to reciprocate this. The rule says x raised to the power of minus a is equal to 1 over x raised to the power of a. That's another rule. That x raised to the power of a negative index will give you the reciprocal of x, which is 1 over x, raised to the power of a. Right? So x raised to the power of minus a equals 1 over x raised to the power of a. So if this were to be 2 now, it becomes 1 over x raised to the power of 2. Why? Because of this. So that's the same thing we are going to apply. So there are like 2 rules we are going to apply. I cannot find the value of x. Okay. So there are 2 rules we are going to apply here. One for the negative index and the other for the fraction. For the negative index, we are going to reciprocate for. Let's take it one at a time. So let's solve the one of the negative index. So we are going to reciprocate this, and for the what now? Fraction, we will get the square root of 4. So we're going to have x now, x raised to the power 1 is x, equal to, negative index becomes 1 over 4 raised to the power of 1 over 2, right? 1 over 4 raised to the power of wealth wise. Thank you very much. Thank you for the roses. Maybe you should explain this since you use 1 over 4 as exponent. Explain this. I've explained that already. Answer is 1 over 4. Okay, let's see. So, this negative is the reason why we reciprocated this, alright? According to the rule of indices. I was not the one from the rule. I'm applying the rule here, okay? So, thank you for the rules. So, we have 1 over 4 raised to the power of 1 over 2, right? So, now what's the next thing? 4 raised to the power of 1 over 2, that's the square root of 4, right? So, that's going to give us, what is square root of 4? Or should I just express it as this? And what's square root of 4? That's 2. So x is 1 over 2. X is 1 over 2. Which class is that? By the way, this is a GCE question. Yeah, GCE question. So which is 1 over 2? The answer is 1 over 2. Yes. Square root of 4 can be plus 2 or minus 2. Yeah. Square root of 4 can be plus 2 or minus 2. So it can be 1 over 2 or minus 1 over 2. You wanted to get rid of 4. Please move on. Some people will be. Okay. I hope we understand. Can we move on? Do we understand what we just did? Can we move on? Thumbs up if you have gotten it. Can I see just those that are following? Okay, good, Larry. Alright, can we move on? Thumbs up, please. Yes, move on. Okay, sure. Good. Repeat the question. I should repeat the question now. I'm not going to go back all over again. Maybe you joined in late. Move on. Yes, okay, let's continue. So number 5. Question number 5. So this question says if 9 raised to the power of 2x plus 1 equals 81 raised to the power of x minus 2 over 3 raised to the power of x. Find x. So this is our question. 9 raised to the power of 2x plus 1 equals. No, we're not going to do initial quadratic equation today, no, because I've not done quadratic equations, so many are not going to understand. 9 raised to the power of 2x plus 1 equals 81 raised to the power of x minus 2 all over 3 raised to the power, or anyone that's even involved in simultaneous equations. So find x, alright? This is the question, so I need to wipe off this, so I'm going to write it just small so that we can have space for working. So 9 raised to the power of 2x plus 1 equals 81 raised to the power of x minus 2 over 3 raised to the power of x. So that's our question. Try finding out how much the bigger board is. Okay. The bigger board with the stand is about 50k. Lion-based production, yeah, it's about 50k. Or 55. Alright, so this is our question. 9 raised to the power of 2x plus 1 equals 81 raised to the power of x minus 2 all over 3x. AMT, thank you for the rules. Now, what are we going to do? Looking at our bases, we have 9, we have 81, we have 3. We can express them to have a common base, right? There's a number that we know. By the way, this number, these are multiples of a number. What number is that? What number can we raise to a power? So different power that will give us 81, power that will give us 3, and power that will give us 9. 3, good. Every base turns 3. Okay, good. Okay, we are following. So 3 raised to the power of 2 will give us 9, right? So we've changed our 9 to 3 raised to the power 2. Now, raised to the power of 2x plus 1. So equal to 81. So let's change 81 also. 3 raised to the power 1 give us 81. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So 3 raised to the power of 4. Hello, Young, welcome. So 3 raised to the power of 4. Raised to the power of x minus 2. So all raised to the power of 3. All over 3 raised to the power of x. So what's the next thing we're going to do? We need to open this up. So we're going to multiply these 2 by this. The same thing we do here. Multiply this 4 by that. Thank you, MT, for the gifts. Thank you. Thank you for the ice cream cone. Vieira, thank you for the rose. Thank you, I appreciate it. Jeremiah. So multiply these 2. That's the first thing. Open up this. Multiply these 2 by this. And also multiply this 4 by this, right? So that's what we're going to do first. So 2 multiplying 2x plus 1. You know that this 2 is not multiplying 2x alone. It's going to multiply 2x and at the same time it's going to multiply plus 1, right? So 2 times 2x will give you 4x and then 2 times plus 1 will give you plus 2. So let me just write it like that. So we're going to have 3 raised to the power of 2 3 raised to the power of 2 in brackets 2x plus 1. Alright? Because 2 is multiplying 2x plus 1, right? 2 multiply 2x plus 1. Hey, thank you, MT. Thank you. So 2 is multiplying 2x plus 1, then equals 4 also multiplying x minus 2. 4 multiplying x minus 2. 3 raised to the power of 4 multiplying x minus 2. Bracket close. Over 3 raised by just x. So now, at this point, we can drop our bases, right? We can drop the bases and then go from there. Oh, before we drop our base, let's solve this. Let's deal with this. Remember the rule that says x raised to the power of a divided by x raised to the power of b. It will give you what? X raised to the power of a minus b. So we are going to use that rule here. That x raised to the power of a, in this case, this is our a, divided by x raised to the power of b, they are going to subtract the powers, alright? So in this case, we'll have this minus this. Larynx. That this raised to the power of this divided by the same base, right? So what you're going to do is to subtract the powers. Young, please add me up. Okay. 3, add me up where, please? 3 raised to, maybe you want to tap on there's a WhatsApp link on my bio. You tap on it and then you find yourself in the WhatsApp group. Alright? So that's when you have this raised to the power of a divided by this raised to the power of b, and both of them are of the same base, just subtract the power. So that's what we're going to do here. This is 3 raised to the power all this divided by 3 raised to the power this. So we're going to subtract the powers, that is this power minus this power. So that's what we're going to do. So we have 3 raised to the power of, let's even open up this bracket, right? We can open up the bracket at once. So let's open up our bracket, expand this right at once. So 2 times 2x will give us 4x. Then 2 times plus 1 will give us plus 2, right? So equals 3 raised to the power of, open up this also. 4 times x, 4x. Then 4 times minus 2, minus 8, right? All over 3 raised to the power of x. I need to be sure that we are following step by step. Do we all understand at this point? Mr. Rob, Mr. York, there's a WhatsApp link on my page. Go to the bio. There's a WhatsApp link you tap on. I need to take you to the WhatsApp group. So this is 3. Yeah, do we understand to this level? Yes, good. Understand. Okay, great. Yes, okay. So what's the next thing we are going to do? We are going to apply that principle that says that x raised to the power of a divided by x raised to the power of b will be equal to x raised to the power of a minus b. So we are going to have 3 now raised to the power of this minus this, right? So we're going to have 3 raised to the power of 4x plus 2 will be equal to 3 raised to the power of 4x minus 8 minus x. So we have used the law here, with the rule here. So we now have this raised to power, this divided by this raised to power this, to now have this raised to the power of this minus this. Do we understand this? Yes, I understand, Timmy. The rule says, again, let me write out the rule. The rule says x raised to the power of a divided by x raised to the power of b will give you what? Because the bases are the same, so what you are going to do is to subtract the power. It will give you x raised to the power of a minus b. So this raised to the power of this divided by this raised to the power of x, and so it's going to give us the same base raised to the power of this now minus x. Exactly. Subtraction rule. Understood? Good. So now, what's the next thing? At this point, we can drop the bases. At this point, we can drop the bases and equate the powers. We can now drop 3 and then now equate the power. So now we can 3 cancel 3, and then we can now say this will be equal to this here. So 4x plus 12 now will be equal to 4x minus 8 minus x. If the base is not the same, because you cannot, if the bases are not the same, then you can't cancel them. Alright, you can't cancel them. Most first one has to be simple. Queen Becky, thank God. Where did the last minus x come from? Minus x, that's this x here. This x here. We apply this rule, the rule that says x raised to the power of a divided by x raised to the power of b will give you x raised to the power of a minus b. So that's what we did here. 3 raised to the power of this divided by 3 raised to the power of this. Now because they are the same base, we'll now say this power minus this power. That's what happened here. 4x minus 8 now minus x. Larry, I hope you get it now. So that's 4x minus 8 minus this x here, because they are both of the same base, and division is what we have here. Okay, good. So now let me wipe up this now. So we have 4x after clearing the bases, after cancelling the bases and equating the powers now, we're going to have 4x plus 2 equal to 4x minus 8 minus x. 4x plus 2 equal to 4x minus 8 minus x. So now what are we going to do? We'll have to collect our like terms, right? We'll have to collect the x's together and the what's it called, and the constants together, right? Collect like that, exactly. Yeah, thank you very much. Right, so let's bring our x's to this side, right? So we're going to have 4x. 4x comes, it becomes minus 4x. I don't want to say add 4x to both sides. Then minus x also. You have plus x, then equals to what? You have minus 8 here. Minus 8. Please, this minus is for the 8. 8 is negative. X is minus. 4x is positive, right? 2 is plus. 4x is positive. So when you're moving, you know what it's moving with, alright? So 4x is here. 4x is positive here. It's having plus here, silent plus, alright? So we moved to this side, you have minus 4x, alright? That was a simple explanation I gave us the last time. So 4x came to this side. Anytime you have a term like this crossing the equal to sign, what happens? It changes. It If it is addition, it will change to subtraction. If it is subtraction, like minus 8, now assuming we are bringing minus 8 here, it becomes plus 8. So we have 4x now. Then we are bringing the x terms here and taking the constant, the numbers over. So 4x positive comes here, becomes minus 4x, right? What other thing? We have minus x here, comes here, becomes plus x, right? So we have all now equal to, so these two, we are going to take it over to meet minus 8. So minus 8 is here now. Plus 2 comes here, what happens? Minus 2. So we have minus 2. So 4x minus 4x. 4x minus 4x, 0. Cancel out. Alright? So we have just x plus x remaining, which is x. So x now equals, what is minus 8 minus 2? What is minus 8 minus 2? Use the same explanation I gave. I'm owing 8, I'm owing 2. Minus 8, I'm owing 8, I'm owing 2. Good, minus 10. I'm owing 8, I'm owing 2, I'm owing 10 altogether. So minus 10. And that's the value of x. Minus 10. Yeah, Larry, it's minus 10. Yeah, minus 10. I hope we understand this. I hope this is well understood. Yes, good, great. Well done. Yeah. Well done. Alright, let's move on to the next example. So example number 6, I guess. Example number 6. Example number 6. So it says that 56x raised to the power of minus 4. 56x raised to the power of minus 4 divided by 14 raised to the power of x raised to the power of minus 8. So x raised to the power of minus 8. 56x raised to the power of minus 4 divided by 14x raised to the power of minus 8. Thank you very much. Thank you. Thank you very much. I'd like to be a lecturer. Don't be. Alright, what are we going to do? Bakra, thank you for the rules. Thank you. What are we going to do? Division, alright? Let's just go ahead. So we're going to have 56x raised to the power of minus 4 division over 14x raised to the power of minus 8. Is there, by the way, is there any number? So you want to check these two numbers first of all. Is there any way that we can have a common base for 56 and 14? Of course, 2 raised to the power of nothing will give you 14. 2 raised to the power of. Why are you not asking for gifts? Okay, please make sure you are giving gifts, alright? Thank you. If you appreciate our work so far, you want to support by giving gifts, alright? Thank you very much. I appreciate the gifts given so far. Yes, okay. The donkey said yes. Yes to what? Yes to a number raised to the power of what number? What number? What number? What number? What number are we going to raise? Are we going to have as a common denominator, or common base rather? 2 raised to the power what will give us 56, and 2 raised to the power what will give us 14. Please explain, Rahim. Okay, I'm going to do that. No common number, great. Okay. But Larex, thank you for the roses. Larex, thank you for the roses. So we have 56x raised to the power minus 4 raised over 14x raised to the power minus 8. What you want to do is just divide this directly because there's no number, right? So if you check 2 times 1, 2 times 2, 4 times 2, 8 times 2, 60 times 2, 32 times 2, 64. No, not 2, not give 1. 3 times 3, 9 times 3, 27 times 3, 60, 81 times, it's even not working. 4 times, nothing is going to work. So let's just, we're going to have 56x raised to the power of minus 4 divided by 14x raised to the power of minus 8. So this is what we have here. This is division now, written in this form, right? So what 14 is a common factor of these two. 14 can divide 56, right? Good. 14 can divide 56. Exactly, 14 and 56 is 4. So we can divide this. Now how about this one? How about this one? We can also divide this using the law, the subtraction law, right? The same x and x. So it's going to give us minus 4 Remember again, so we have x raised to the power a divided by x raised to the power b is going to give us x raised to the power what? A minus b. X raised to the power a divided by x raised to the power b, or x raised to the power a over x raised to the power b. Whether I write it this way or I write it this way, the same thing. It's going to give us what? X raised to the power a minus b, right? So we can apply that for this x raised to the power minus 4 and x raised to the power minus 8. And also we know that this can be divided by this, right? So 56 divided by 14 is 4. Here 1, here 4. Then x raised to the power minus 4 divided by x raised to the power minus 8. So our answer will be 4x raised to the power minus 4 minus 8. I know someone is going to tell me, why is this like this? So 4, this has been divided, we have 4 now. So x raised to the power minus 4 divided by x raised to the power minus 8. The law of subtraction says that because they are the same base, we subtract their powers. So what's the power here? Minus 4, right? Then minus this minus, then minus 8. Do you understand what we did here? Do you understand what happened here? It's just like saying x raised to the power a over x raised to the power b will give you x raised to the power a minus, so the division brought about minus and b, right? So if this were to be minus b, it's going to be minus b, minus whatever you have here. Whatever you have here, minus whatever you have here, right? So in this case, what we have here is a negative index, minus 4. Then minus what we have here, minus 8. I know some will be confused. Aisha, I know, I had to explain that. So x raised to the power of minus a over x raised to the power of minus b is still the same rule, alright? So you're going to have x raised to the power of minus a minus what you have here. X raised to the power of what you have here, which is minus a, minus what you have here, which is minus b. That's what we did here. So x raised to the power of minus 4, which is what we have here, minus what we have here, which is minus 8. Got it? Good, okay. So now, minus times minus, remember that minus times minus equals plus. And plus times plus equals plus. Then minus times plus equals minus. And plus times minus equals minus. In other words, if you are multiplying two numbers that are negative, it will give you positive. If you are multiplying two numbers that are positive, it will give you positive. If you are multiplying two numbers that are one is positive, one is negative, one is positive, it gives you negative, but one is positive, one is negative. So if they are the same, like minus 2 times minus 2 will give you a plus 4. Plus 2 times plus 2 will give you a plus 4. So if the two are having the same sign, minus minus, you get plus, or plus plus, you get plus. But if they are different, one is negative, one is positive, you're going to get minus. So now, minus times minus here will give you a plus. So minus multiplies minus 8 here, alright? So you're going to get plus 8. So we have this now giving us equal to 4x raised to the power of what? Minus 4 minus times minus 8 plus 8. Understood? You're welcome, Queen Becky. Do you understand that? Do you understand what happened here? How we got this? Do you understand? Yes. Okay, good. So equals now 4x. So what is minus 4 plus 8? What is minus 4 plus 8? Good. Good. What is minus 4 plus 8? What is minus 4 plus 8? Good. 4 plus 4. Yes, 4 plus 4. Exactly. So I am owing 4. I have 8. I am owing 4. I have 8. Again, let me write it here. Negative, see that's what you owe, plus see that's what you have. An easy way for you to get this, alright? So if you see minus, see that's what you are owing, and you see plus, see that's what you are having, alright? So in this case, like I'm owing 4 and I have 8, alright? So for what you have to pay what you owe, alright? So out of the 8 that I'm having, I'm going to give out this 4 that I'm owing. What it means is that I still have 4 more, so my answer is what? Plus 4. What if it is minus 8 plus 4, the other way around? What if it's minus 8 plus 4? So I am owing 8, but I have 4. I'm owing 8, I'm to give out 8, but I have 4. So what I have is not even enough to pay what I owe. So when I give this 4 that I have, it means I'm still owing 4. And now the what? Minus 4. Alright? Thank you, Cassidy, for the roses. Thank you. So what do we have now? Thank you for the roses. Thank you. So you have 4x raised to the power of what? 4. Are we done? Yes. C'est fini. That's the answer. 4x. So we've simplified this. We divided this now. Nothing else can be done here. And so that's our answer. 4x raised to the power of 4. I got it right. Good. Well done. Yeah, Abdulganiyu. Good. Nice. Any question on this? Any question? Can we move on? Can we move on? Let's do differentiation. Not yet. Not yet. We're still doing this one, and many are yet to understand. You want us to go to. We're still trying to get the basic. All right. So, can we move on? Yes. All right. We'll do differentiation and all of that later on. We've not even done quadratic and all that. The next question. I guess this probably maybe be the last question, and then I give us an assignment. So we have 5. Let me bring. I think I have a question. Okay, let me just give us 2 questions to solve. All right. All right. Let me give us 2 questions to solve. So the first one, this is our quick exercise, all right, to test our knowledge. Yes, I'm on YouTube. Learn with Austin 101. Learn. So question number 1 says 32. Okay, no, let me not give that stuff. Okay, let me give us this one. 8 raised to the power of x equals 0.25. 8 raised to the power of x equals 0.25. Everybody solve. Let's solve. Let's test our knowledge. Let's apply our knowledge here. One more example. Okay? This is still part of it though. But let's solve first, then I'll work on this one. So 8 raised to the power of x equals 0.25. Let's solve this one. Find the value of x. Everybody. Get a paper, get something and solve. Everybody. I want to see our answers when we're done solving. I want to see our answers. So we have 1 minute or 2 minutes. 1 minute. Too much though. Let's solve. This is very simple. Let's solve. Let's be sure that we are following, we are learning. If you are getting knowledge so far, you want to do well by gifting us, alright? Let the gift flow. Because let us gift the teacher. So all these good teachers, not even a life coach. Yes, so let's gift the teacher. Alright, are we done solving? Thank you, Sarah Knight. Are we still solving? This one is very simple. Answer is 2. Okay, you're done. BC Kitchen. Okay, good. Let's see if you are correct. When we're done, then we'll check if you're correct. BC Kitchen says 2. Tweet says -2. Purity says -2/3. Log formula can solve it. Okay, we're not doing logarithm yet. Log hence purity says -2. The answer is 0.031 trend.ing. Stuart -2. Okay. Find cos phi. Michael says 0.03. AY says -5. Omni says 256. Really? Okay. Aisha says 2. Prime says 0.031250. Wow. Alfonso says -2/3. Okay. What's the question? The question is on the board. 8 raised to the power of x equals 0.25. Solve for the value of x. 8 raised to the power of x equals 0.25. Solve for the value of x. And that reminds me, while we're still working, that reminds me, if for those that have been asking like a private class, or you are preparing for the NECO exam, or you're in the secondary school unit, I am setting up a private class, alright, for this one. So I need just 10 people and then we start. If you are interested, please send me a private message, that's a DM. Maybe after this class, you send me a DM so I need just 10 people, alright? 10 people, I will create a WhatsApp group for you. If we have class, probably can have class maybe 2 or 3 times in a week. So when we have class, I'm going to send the link in there, then we join, probably on Zoom or any other platform. Then we join the class. Okay, so if you are interested, send me a DM after the class. So are we done? Minus 2, let's see. 8 raised to the power of x equals 0.25. 8 raised to the power of x equals 0.25. 8 raised to the power of x equals 0.25. So what do we want to do, alright? First thing, change your decimal to fraction. Change your decimal to fraction, alright? So what will 0.25 be as a fraction? What will 0.25 be as a fraction? 0.25, can we change that to fraction? What will it be? Because that's the first thing you want to do. Change your decimal to fraction. 25 over 100, good. So we have 8 raised to the power of x equals 25 over 100. 25 over 100 can be broken down, can be simplified to the lowest term. What will it give us? If we divide this, 25 over 100, good, 1 over 4. So we're going to have x raised to the power of x equals 1 over 4. And now, let's write this 1 over 4 as an index, in index form. What will it be? Change this 1 over 4 to index. What will it be? What will this be? 1 over 4, let's write it as index, in index form rather. What is it going to be? 1 exponent minus 4. Okay? I'm waiting for others. 1 over 4, what will it be? 4 to the power of minus 1. So that's what it's going to be. 8 raised to the power of x equals 4 to the power of minus 1. 4 raised to the power of minus 1. 4 and negative 1 index. That's what you're going to have. Now, we want to change this, alright? So that we're going to have a common base. What can we use? Base what? 4 power 1, yes, Larix. So what can we do? What can we do here? Let's change this number so that they have the same base. I don't understand how we got 1 over 4. 25 over 100, we broke it down, alright? So 25 over 100. 25 here 1, 25 here 4. So we have 1 over 4. Or that's Gmo, I guess, yeah? So you divide with a smaller number. 25 over 100. 5 here 5. 5 here 20. 5 here 1, 5 here 4. So you have 1 over 4 with whatever way. I believe you got that now. So, what was the question? Yeah, what can we do? What can we do to this? 4 raised to the power 2. 2 to the power of minus 2. Yeah, we can express both of them now in base 2. So 8, what can we, to what power are we going to express 2 to give us 8? That will be 2 times 2, which is what? 4 times 2, which is what? 8. So 2 raised to the power of 3. I hope I'm communicating. Good. 2 raised to the power of 3. 2 raised to the power of 3. That's your 8, right? So raised to the power of x. Then for 4, what do you have? For 4, what do you have? Good. 2 raised to the power 3. 2 power 3. So what will you have for 4? 2 to the power of what? What are we going to raise 2 to what? To what power? 2 raised to the power 2. Good. So you have 2 raised to the power of 2. Raised to the power of negative 1. So raised to the power of minus 1. Then what's the next thing? We are going to multiply our powers, right? So 3 times x. You have 2 raised to the power of 3x. Then equals 2 times minus 1 will give you minus 2. So equals 2 raised to the power of minus 2. So who can tell us what next are we going to do? What is the next thing we are going to do? What are we going to do next? Get rid of the basis and deal with exactly. So we are going to get rid of the basis, cancel out the basis, drop the basis, whatever way you want to say it. And then what? Equate the powers. Cancel out the base, exactly. So now we're going to have 3x equals minus 2. 3x equals minus 2. 3x equals minus 2. What's the next thing we are going to do to get the value of x? Because what we need is x, right? Yes. So what we need is x, right? So what are we going to do to get the value of x? Divide both sides by 3, exactly. So we have over 3 n over 3, right? So 3 eliminates 3, 3 cancels 3, and x now equals that. So x equals minus 2 over 3, now that's the answer. So x equals minus 2 over 3. X equals minus 2 over 3. So how many of us got the answer correct? Who are those? God bless you. Bless you too. Thank you very much. Bra Collins. How many of us got the answer correct? Me, Swat. Well done. Hey, Queen Benny, you got it. Well done. Good. I got it. Okay. I got it. Again. Elvis. Okay, good. Elvis. Thank you. Never understood before. Good. Well done, everybody that got it correctly. Well done. Well done. Richly bless you too. Thank you. All right, let's go to the second question. So the second question. Question 2 says 2 raised to the power of 3x minus 1 equals 4 raised to the power of x plus 3. Alright, let's solve this one. This should be easy. 2 raised to the power of 3x minus 1 equals 4 raised to the power of x plus 3. 2 raised to the power of 3x minus 1 equals 4 raised to the power of x plus 3. 2 raised to the power of 3x minus 1 equals 4 raised to the power of x plus 3. Solve. I'm waiting for our answers. 2 raised to the power of 3x minus 1. If you are coming here to tell me what to do, I'm going to block you. You're not the one to tell me what to do, alright? You call me, there's a topic at hand, you join in or you get lost. So 2 raised to the power of 3x minus 1 equals 4 raised to the power of x plus 3. You come in, you meet people doing something and you say you want us to do what you want to do. Really, does that make sense to you? Is that wisdom or what? 2 raised to the power of 3x minus 1 equals 4 raised to the power of x plus 3. Okay. Oh, people are only getting the answers. 7. Nice. Good. Steve, 7. Abubari, 7. Great. 7. Good. 7. Okay. Alright, people are getting it. 7. I'm not saying it's correct though. 7. Okay. 3 over 7. 7. Good. Okay. 7. Shama. Ronaldo. Okay. Drop on that one too. I get the answer. Okay, 7. Alright. 7. Yeah, thank you, Abu Bari. Thank you. Change base, then you got your linear equation. Okay. 7. Okay, I don't need capital. Okay, nice. Alright, let's continue. So we have to express 4, right? First of all, to what? We have to express 4, right? Let it be 2 raised to the power of 2. Good. So we're going to have 2 raised to the power of 3x minus 1 equals 2 raised to the power of 2 raised to the power of x plus 3. Alright? So 2 raised to the power of 3x minus 1 equals 2 raised to the power of 2 raised to the power of x plus 3. Okay? So now we're going to multiply these powers here. We multiply 2 by x plus 3. So you have 2 times x plus 3, and 2 multiplies this, you have 2x. 2 multiplies plus 3, you have plus 6. So you are going to have 2 raised to the power of 3x minus 1 equals 2 raised to the power of 2x plus 6. Alright? So what's the next thing? We are going to eliminate the base. Alright? Drop the bases and then equate the power. It's minus 3. Okay, let's see. So my 2 cancel 2, and you have 3x minus 1. 3x minus 1 equals 2x plus 6. 3x minus 1 equals 2x plus 6. Then what's the next thing we're going to do here? We're going to collect like terms, alright? So bring the x's one side and take the constant, the numbers the other way. So we're going to have 3x, then plus 2x comes over, becomes minus 2x, alright? So equals 6 minus 1 goes over, becomes what? Plus 1. So 3x minus 2x gives you 1x, alright? Of course, we don't write 1x, we write it as x because 1x is x, so that's x equals 16 plus 1. Same thing, that's the answer. Oh, you got it now? So that's our answer, x equals 7. One more, and that will be the last one for today. Let me give us one more. So let's solve this one. So we have a simplify, okay? Simplify a raised to the power of 3 times 125 raised to the power of, okay, bracket close, all raised to the power of 2 over 3. So let's simplify this. A raised to the power of 3 times 125 all raised to the power of 2 over 3. Infinity, you got it, great. So simplify this. This one go hard, are you sure? Simplify, bracket open, a raised to the power of 3 times 125 all raised to the power of 2 over 3. Okay, let me give us some of the rules. Remember the rule that says x raised to the power a, y raised to the power b, raised to the power c would be what? X raised to the power ac, y raised to the power bc. So that comes into play, yeah? And another one we want to apply, remember also the other rule we want to remember is the rule of fraction that says what? X raised to the power, let me use a over b now, will be equal to the bth root of x raised to the power a. Alright, so let's solve. Elarex, you can't do this. Are you giving up already? Okay, I'm waiting for those that are working. Oh, sorry about that, the kind. I never knew you were still writing. Okay, let's solve. Let's solve. 5AP of 2. Oh, okay. Oh, Joy, do you think that? 25a squared x. 25a squared x. There's no x here, it's actually times. A raised to the power of 3 times 125, all raised to the power of 2 over 3. Alright, no x there. No x there. 25a squared, okay? Incident based Sunday, okay? 25a squared. Yes, we are doing the explanation. X was added by mistake. Oh, okay. 25a squared. 25a squared. 5 raised to the power 3. Okay. Answer is 25a squared. All right. Let's solve. So, solution. So we have this now. A raised to the power of 3 times 125, all raised to the power of 2 over 3. Now, this thing here, you are seeing here, this power, you are seeing out of the bracket. What it means is that it is affecting everything in the bracket. So, it is this affecting this, and it's also affecting this, right? It's affecting this one, and it's also affecting this one. Let me write out that rule again. It says if you have a raised to the power, okay, if you have x raised to the power a and y raised to the power b, like in this case, this times this is also this times this, right? All raised to the power c. The c will affect this, and the c is also so by distribution. So you're going to have x raised to the power a times c, then y raised to the power b times c. That's what you're going to have. So you're going to have this. You're going to apply this here also. So you're going to have this affecting this and also affecting this. So you're going to have a raised to the power of 3 raised to the power 2 over 3, right? Raised to the power of 2 over 3, then times this 125 raised to the power of 2 over 3. 125 raised to the power of 2 over 3. Do I put in the bracket? No, it's not. Let me just leave it like this. Do you understand what I did here? Can I continue from here? What we did is to open up this bracket by saying this raised to power this and this raised to power this. It's just like algebra. So you have 2 in brackets, a plus 5. These 2 will be affecting everything in the bracket. 2 times a, then plus 2 times 5. Okay, continue here. Okay, good. So this raised to power this, then times this raised to power this, right? Yes. So what is this now? This power will multiply this power. 3 times 2 over 3. 3 times 2 over 3. 3 here 1, 3 here 1. That's 2, right? 2. So that's a raised to power 2. That's what this is giving us. A raised to power 2 times this. We only have this here. Nothing is multiplying. Remember the fraction index, the fraction rule that says x raised to power a over b is the same thing as what? The bth root of x raised to the power a. X raised to power a over b is equal to the bth root of x raised to power a. So 125 raised to power 2 over 3 will be equal to the 3 root, third root, that's the cube root of 125 raised to power 2. So that's the cube root of 125 raised to power 2. Cube root of 125 raised to power 2. Alright? So what would that give us? The cube root of 125 raised to power 2. So we have a squared. What's the cube root of 125? What's the cube root of 125? What number times itself will give us 125? That's 5. Because 5 times 5, 25. 25 times 5, 125. So we have the cube root of 125 to be 5 square. Okay, we still have square. 5 square. So we have 5 raised to power 2. What is it going to give us? Or let me just write it there. So that's 5 square. Alright? So this is a square. What is 5 square? 25, right? So a square times 25. What is it giving us? And that is the answer. So the solution to this is this. So simplifying this gave us 25 a squared. So I saw a lot of people getting that answer. So well done. Everybody that got the answer. Well done. Yes, Elegant, I saw yours. Abdulgani, I saw yours. Well done. Yes, well done. Okay, that brings us to the end of today's class. I'm just going to give us an assignment at this moment. Assignment. Assignment. 2a over 3. Remember to invite me in your next class. Okay, the guy, just make sure you are following me. Please put on all notification.